Hi, my name's Tyson. Today I'll be presenting to you the Autonomous Recycling Separation System, a proposed design for waste management companies. So there's a lot of problems with waste. Humans generate a lot of it. And when we have waste, we normally dump it in two places, in landfills or the ocean. This has a bunch of negative impacts on the environment, namely leachate can contaminate the groundwater and soil. Greenhouse gases can contribute to global warming, and ocean dumping can endanger our wildlife. So what's the solution? Well, we can recycle. Recycling not only conserves resources and energy, but it minimizes environmental damage. Now, when we talk about recycling, we normally think of single stream recycling. Everything's collected in one yellow bin, taken to a big material recovery facility before it gets hand sorted. Now, this is where the problem lies because hand sorting is really inefficient. We can automate this process. By using a robotic arm and a couple of sensors. So what do we want to do with automation? We want to be able to sort it into different streams, namely paper, cardboard, glass, aluminium, etc. What we want is an input of a single waste stream on a conveyor, and the output will be multiple waste streams separated into different receptacles. But this is a very hard problem. When you think about waste, there's so much variability. How can you classify it? Well, we can use a whole bunch of sensors. So the sensor unit in the proposed design has a 3D laser sensor, that's a height map for object identification, a few near-infrared sensors for obtaining spectroscopic data of the material, and a camera for finding gripping points. Now, what we can do is we can fuse this sensor data, extract all relevant features that we want, and we can feed it into a supervised machine learning algorithm. What this will do is it will build a statistical classification model for us, and that will allow us to categorize materials probabilistically. So the proposed design uses an ERB 1200 and a robotic 2F140. Now, these were chosen for their suitability and compatibility, namely they're really fast, they're really nimble, they're compact, they're safe, they're flexible. And on top of that, they can generate really high cycle times. My calculations found that 1.56 second cycle time. The duty cycle was reaching 95%, and the OEE was 71.7%, which is pretty close to the 80% benchmark. In terms of the cost analysis, we can see that there was a 38.5% increase in throughput, 27.8% decrease in cycle time, and 280% increase in utilization. So overall, automated sorting is looking very positive. In terms of the net annual savings, it was over 146,000 with a payback period of just over 1 year. So what are the benefits of this system? Well, it can consistently and accurately sort recycling much better than humans can. With machine learning, it's very flexible. It doesn't just have to be waste, it can be commercial waste as well and industrial waste. Minimizes labor requirements, improve productivity and performance, and you can add extra robots to it to increase its overall performance. But overall, automation has more production, faster operation, longer working hours than human counterparts. In conclusion, automation has a cost of up to 10 times lower. The net annual savings is up to 3.5 people's worth of wages. That's per year. There's a very acceptable payback period of just over a year, and overall this is a great return on investment. Now, in terms of the simulation, I wasn't actually able to get a simulation working, so I've got a pseudo-simulation here. So what we have here is we've got the robot cell. It's got 5 parts to it: the robot arm, sensor unit, conveyor, receptacles, and the enclosure. You have an item, it gets placed on the conveyor, it then moves towards a sensor unit, where the sensor unit will detect what sort of material it is and the gripping location. It will then move within the working space of the robot, where the robot will begin at home position. It will move to the object position, close the gripper, pick up the item, move to the suitable receptacle depending on what the classification was, what it was labeled. It will then release the item and return back to home position, and that all happens in 1.56 seconds. Thanks.